Hi everyone, I'm Jeff from 4SD.
I'm Rashwin from 4SD.
I'm Clement from 4SD.
And I'm Arthur from 4SD as well.
Today, we'll be doing our project-based learning PBL of Chemistry Form 4. The theme of our project is interaction between matter, and the learning area are Chapter 6, Acid, Bases and Salts. The standard of our content, acid-base indicator and pH value of acidic and alkaline substances. In this video, we'll be using red cabbage as a natural pH indicator to test the acidity and alkalinity of different household solutions. Red cabbage contains a pigment called anthocyanin, which changes color depending on the pH value of a solution.
Okay, so next, we're going to move to anthocyanins. What are anthocyanins? Anthocyanins are natural chemical compounds with antioxidant properties and produce pigments that give red, purple and blue plants, fruits or vegetables for their rich coloring. Some examples of fruits, vegetables and plants that contain anthocyanins are berries, cherries, grapes, plums, purple cabbage, eggplant or aubergine, purple sweet potato, red onions, pomegranates, red hibiscus and red rose.
The aim of this experiment is to investigate how the color of red cabbage indicator changes with solutions of different pH. The hypothesis is the color of red cabbage indicator will change progressively across the pH scale. Next, the materials that we use are red cabbage, distilled water, lime juice, vinegar, baking soda powder and Clorox. The apparatus are blender, 500 ml containers, 500 ml measuring cup, electronic scale measure, measuring spoon and colander.
First of all, to make our pH indicator, we'll add 200 ml of water in our measuring apparatus. So next, we're going to peel some red cabbage and put it in the blender to blend it along with the 200 ml water to get our red cabbage solution.
Okay, so now we'll blend.
We filter out the solution.
To collect the pH indicator. Label 9 test containers 1 to 9 and prepare solutions as shown. Next, add the 30 ml of pH indicator to each test and stir gently. Observe and record the color changes. Lastly, plot a pH scale.
From the pH scale created using the red cabbage indicator, it was observed that the color of each solution changed according to its pH value. Acidic solutions such as lime juice, which is pH 2, and vinegar, which is pH 3, turn red and pink respectively. This shows that red cabbage indicator becomes reddish in the presence of acids, which has a low pH. As the acidity decreases, for example, 50% vinegar at pH 4 and 25% vinegar at pH 5, the color gradually shifted from red to purple. This indicates a transition zone between acidic and neutral conditions. Neutral solution, which is water that has a pH value of 6 to 8, showed a purple color. This means red cabbage indicator remains purple around pH 7, confirming it can be used to detect neutrality. Weak alkaline solutions such as diluted baking soda solution, which has a pH value of 9, and baking soda solution, which is pH 10, turn blue and blue-green respectively. This shows that red cabbage indicator changes to blue or blue-green in mildly basic solutions. Stronger alkaline solutions like 10% Clorox, which is pH 11, and pure Clorox, which is pH 12 to 13, turn yellow-green and yellow respectively. This demonstrates that the indicator becomes yellow-green or yellow in strong alkalis, which has a high pH value.
Okay, next, we're going to move on to the comparison part. The red cabbage indicator and the universal indicator both demonstrate how color can be used to determine the acidity or alkalinity of a solution. So in this experiment, the color changes observed is from red in acids, purple in neutral to green in alkalis, follow the same general pattern as the universal pH scale. Although the red cabbage indicator is less precise, it is safe, natural and effective alternative for visually showing the pH changes. Therefore, this supports the hypothesis that the color of red cabbage indicator changes according to the pH value of a solution, making it reliable natural pH indicator for basics experiments.
For the conclusion of this experiment, first of all, what I knew before the experiment. I knew that the pH scale measures how acidic or alkaline a substance is. I also knew that red cabbage can be used as a natural pH indicator, but I didn't know how its color changes for different solutions. Next, what I wanted to know before this experiment, I wanted to find out whether the color of red cabbage indicator changes according to the pH value, and how its color range compares to a universal indicator. I also wanted to identify which common household substances are acidic, neutral, or alkaline. Lastly, what I learned after conducting the experiment, I learned that the color of red cabbage indicator changes clearly across the pH scale. For example, it changes to red or pink in strong acids like lime juice and vinegar. It also remains purple in neutral solutions like water, and it also changes its color to blue or green or yellow-green in alkaline solutions like baking soda solution and Clorox. I also learned that the red cabbage indicator behaves similarly to a universal indicator, but with less precise shades. It's a safe, natural, and environmental friendly alternative for demonstrating pH changes. For the reflection and thoughts after I conducted this experiment helped me understand the relationship between pH and color change, and showed how natural substances like red cabbage can be used for simple yet effective scientific investigations.
That's all from us. Thank you.